do percents show the relationship between quantities? Think about this question during the lesson. Diego starts a 12-hour road trip with his phone's battery charge at 75%. Given his normal usage, will his phone last the whole trip? To solve the problem, start by looking for relationships. How many hours will the phone last when the battery charge is at 75%? As a first step, Diego can draw a bar diagram to represent the hours remaining and the battery charge. The top bar represents the battery at full charge, or 100%. Starting with a battery charged to 100%, Diego's phone will last 15 hours with normal use. The bottom bar represents the battery's charge when Diego begins his trip. Diego needs to find out if the battery will last the 12 hours he'll be on the trip. Diego can now write equivalent ratios to represent the hours remaining and the battery charge. 75 divided by 100 equals x divided by 15. Why were the ratios 75 divided by 100 and x divided by 15 used? 75 divided by 100 is 75%, which is equivalent to x divided by 15, the ratio of battery use remaining to the total battery use. Step 2. Diego can use the equivalent ratios to solve for x. 75 divided by 100 times 15 is equal to x divided by 15 times 15. 11 and 25 hundredths is equal to x. 75% of 15 is 11 and 25 hundredths. That means the remaining battery life is 11 and 25 hundredths, so the phone will not last the whole 12-hour trip. Diego, you'd better pack your charger. Now you know how to use a percent to show the relationship between two quantities.
Kita's phone had a fully charged battery. With normal usage, her phone will last 18 hours. How much time is left on Kita's phone battery at 12% charge remaining?
So to solve for how much time is left on Kita's phone battery at 12%, we need to follow the steps. So the first step is putting the percentage total, which is 100, over or under the 12% that is being used. And we also have to put X, which is going to represent the hours of use, and the bottom denominator is equivalent to the 100, which is 18 hours. So at 100%, there's 18 hours of use. At 12%, we don't know how many hours of use, so that's what we're solving for. So on the next part, we still put 12 over 100, and then we're multiplying that by our 18. And the reason for that, if I put it over here, because you have to multiply by 18 on both sides of the equation, because that equal sign represents an equation, and that's how we have that on both sides. So we're multiplying that by 18. I'm just rewriting it again down here. So that's what that all means. We're multiplying by 18. Once we take that 18 and we're going to multiply it by 12 over 100, we will get 2.16, or 2 1600ths, and that will give us the X. So the hours remaining on Kita's phone is 2 1600ths. So I wanted to make sure that I showed you the math for this part. 12 over 100 times 18. I'm just going to write it over 1 because we know that whole number over 1 is a fraction. So when we multiply 12 times 18, you get 216, and that's going to be over 100. And then you divide the 216 and 100, and then that's how you get that decimal 2 and 16 hundredths. So I wanted to make sure that I showed you that even if you use the calculator, you have to know what to put in the calculator.
A full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many teeth are there in a full set of adult teeth?
As you can see, the diagram shows us there's 20 baby teeth and then all of the adult teeth. They show all the different kinds of teeth that are added to our mouth as we age. So now the bar diagram is what they want us to use. So we have the adult teeth is 160% as many. So that T represents that adult teeth. And then 100% is representing the baby teeth. So now we write that as an expression or equation. We have our equivalent ratios. We have 160 over 100. That's showing the percentages of the adult teeth over the percentage of baby teeth. And T again represents adult teeth. And then 20 is the baby teeth. So we have a 20 there. Then we have to solve for T. So we're going to multiply that 20 on both sides of the equation. So we have 160 over 100 times 20, and then T over 20 times 20. And then that will cancel out the 20 and 20 over here. So we're left with our T. And then 160 times 20. Let's do the math. 160 times 20 is equal to 3,200. And then 3,200 over 100, you divide it and it equals 32. So the number of adult teeth is going to be 32 adult teeth. Step 1, draw a bar diagram to represent the problem. Then write the equivalent ratios. So we have our X miles of that 27%. The 100% of that distance is 93 million miles. And we have the ratios written after drawing that diagram. And we have X over the 93 million. And then we have the 0.227% over the 100%. And then now we have to solve for X. And we have the X over 93 million is equal to the 0.27 over the 100. We multiply the 93 million on both sides, and then 93 million times the 0.27, and then whatever that equals, you divide it by 100, and you get 251,100 as the miles from the distance from the Earth to the Moon. They want us to check for reasonableness. So you would estimate 93 million. It has it here as 100 million, and then the 0.27 to 1%. And then following the same steps, you get about a million miles. 0.27 is about 1/4 of that 1%. So the distance is about 1/4 of a million, which is 250,000 miles. So the exact distance is close to the estimated distance, so the answer that we got is reasonable. Let's try to solve. Let's do number or letter. Let's do B. Okay, so now let's do B, and there's multi-steps, so follow along. We have 162 and 5/10% of 200. So this percentage is greater than 100%. So we want to make our decimal represent a number out of 100%. So I'm going to write 162.5 over 100 times 200. So first I must divide 162 and 5/10 by 100, and I'm using a calculator. That gives me 1 625 thousandths times 200. Now I multiply that by 200 and I get 325. Okay. Now I feel like I should probably do another one. So I'm going to do A as well. So let's look at A. Use a different color. A is 0.08%. So that's 800ths% of 720. I want that number to be represented out of 100. So I'm going to put that number 0 and 800ths over 100 times 720. So I'm going to take that 0.08, divide that by the 100 because I want it to be a number represented out of 100%. And I'm using a calculator and I get 0 and 0.0, that's a 0.0008 over, I'm sorry, not over anything. I'm sorry, I didn't mean to do that. That's what we get once we divide it, and you multiply that by 720. And you should get 0 and 500, sorry, I can't write, 576 thousandths. And that is your 0.08% of 720. Now I want you to try doing C following the same steps that I did in A and B.